Hi, everybody. Thanks for attending. I know it's late for some of you, it's early for others. This whole 24-hour cycle of this conference is fascinating. I hope everybody is doing well. I hope everybody's healthy and able to stay safe. This is going to be a demonstration of Illuminated Cloud. I'll talk more about what that is in just a moment. It is going to be a demo of more recent features, and we'll have some Q&A at the end. Please hold questions until the very end so that I can get through the demo, and then I'll be happy to answer anything that you want. Before we dive into the demo, though, let's look at some conference-specific items. Okay, so I'm Scott Wells. I'm the developer of this tool I'm about to demonstrate, Illuminated Cloud. Illuminated Cloud is a Salesforce IDE. It's a plugin for the JetBrains family of IDEs, which I think are some of the best-in-class IDEs out there, and it builds upon their considerable feature set so that you can do Salesforce development. Apex, Visualforce, Aura, Lightning Web Components of Salesforce metadata, deploying and retrieving metadata, analyzing things, tools that allow developers to interact with their connected organizations, things like that. Again, this won't be a broad overview demo. Those are already out there. It's actually going to be a demonstration of features over the last 9 months to a year that have not actually been featured in this type of a demo environment yet. So, like I said, please hold questions until the end, and I'll be very happy to answer them then. And otherwise, let's just dive in. Okay, so here we are. I'm going to go ahead and begin with something completion related, but this is not just standard completion. This is actually a new feature called Smart Completion, and I think that probably just demonstrating it will help it make the most sense. So in this case, I want to get completions off of the date class, for instance, but in particular, I want them to be assignable to a date value. As you can see, this is in an assignment expression. So if I just press Control Space, that's standard basic completion. You can see it returns things that would not work there, things that are of return type void, integer, Boolean, things like that. Smart completion takes into account the expected data type at the point of insertion. So Control Shift Space instead of Control Space. And so you can see that it's now filtered down to exactly those. And the same thing would hold here. It would only show date time versus you can see like the class constant there. This is useful when you're creating constructors, and it knows about things like type inheritance relationships, things like that. So if we said something like S-object, obj equals new, and then I hit Control Shift Space, it's only going to show the things that are assignable to an S-object. So it's actually showing the S-objects in the system. If instead I just did Control Space, it's showing all the data types in the system. So as you can see, that's going to help you to focus on what you're doing. This is particularly useful when you're filling out call parameters. So for example, here, this is, the first parameter is always a string. The optional second parameter is an integer. And if I press just Control Space, it shows me a bunch of things that don't make sense. Control Shift Space, and it's going to allow me to fill out this, invocation very, very quickly. Only the integer ones are shown, things like that. If you're using an S-object specialized constructor, it knows about the, say, the field on the left-hand side. It knows the data type of that field, and it's going to show you only things that are assignable to that data type. And that's not just off of the first completion. In this case, for example, off of this map, it's only going to show you the things that evaluate to a string because it knows that name is a string. Versus if I just press Control Space, it would show me everything, basically. So scrolling down, some other places that this is useful, and I'm not going to go through every single one of them because I have quite a few things that I'd like to cover. Here's a relational expression. The left-hand side is an integer, so the right-hand side needs to be something that can be evaluated from a relational standpoint against an integer. So again, Smart Completion is going to show you something there, only the things that can be related to an integer. Here's a nice use case for it. This is a pick list field. It has a constrained set of values. If I just use completion, it's going to show me everything. If I use Smart Completion, it's not just going to show me things that can be assigned to a string. It is actually going to show me the string literal constants that correlate to the known values of that pick list field. So that's definitely a nice use case for it. Similar to that, I'm going to go ahead and scroll down a little bit. If you're trying to get an enum value, whether you're trying to assign to it or use it as a method parameter or whatever it happens to be, Control Shift Space will actually show you just those enum values. So a new completion capability smart completion as opposed to basic completion. They actually are complementary to one another. If an expected data type is available, use smart completion. It will degrade gracefully to basic completion if it can't find anything. And otherwise, you're just going to use basic completion. So it's not an either or type of situation. All right. Moving on from completion, let's talk about static code analysis real quick. So static code analysis is basically not only syntax validation in the IDE, but semantic validation in the IDE. And Illuminated Cloud's had quite a few rules for this, or rather capabilities for this since Illuminated Cloud 2 was introduced. Here's one that has been there. It's an unused declaration inspection. It'll find dead code for you, which is obviously extremely valuable. And if you want, there are always quick fixes available, or there are often quick fixes available. So in this case, it would allow you to remove that unused declaration. These symbols that are all red are things that can't be resolved. So it's been able to detect this for a while, but let's see what it can actually do now. So let's say that I'm doing test-driven development. I'm going to sketch out my API that I actually want to have, but I'm going to fill in the body as I build out the tests, kind of a TDD tenant. Well, I can use Illuminated Cloud. It knows that this should be a type based upon where its position is in the overall syntax, and it's going to prompt me to create as a type. So I'm going to go ahead and create as an inner class, and it will walk me through the modifiers to make sure I make it complete. And then I'm going to do the same thing for Session Builder. I'll do it as an inner class so that we can see things evolve. And then I'm going to do the same thing for this method. I'm going to go ahead and have it stub out this method. Now, an interesting thing happened here. It doesn't know the data type of the parameter. It added a nice name for the parameter based upon the expression that drives that parameter, but it doesn't know the data type because that is also an unknown symbol. So let's just go back up here and see if we can do better than that. So let's go ahead and have it stub out an inner enum called session type, and we'll go back to where we were, and we'll go ahead and have it add an enum constant. And now I bet we can do better with this method. So create method. And now this is actually a builder pattern, so it is not able to infer quite that. So we don't want it to return app session. We want to return another session builder. And it got the data type right. And so now let's go back and let's have it create the factory method for this. And so now it has built out that builder pattern, and you notice that everything hangs together at the top. So I'm gonna stop there with the create unresolvable declaration, but you get the idea that you can very quickly stub things out. And the nice thing is this is generally how your brain works. I need to invoke a method here. I need to do something. Well, that method doesn't exist. Okay, well, let's go ahead and make it exist. Okay, now I can fill out what it does, but I'm going from what it is I'm trying to do to how I do that thing. That's really, for most people, the logical way that their brain flows, and you don't have to interrupt your flow by going down, stubbing out the declaration, coming back, putting in the invocation, then coming back, and filling in the actual implementation. Okay, so let's move on to another class of static code analysis capabilities. These are going to be about agreement, and by agreement, in this case, I mean modifiers and annotations. The canonical example of this would be as you're building out a class hierarchy, the base class generally has to have some abstract or virtual modifier, as do the methods, and the extending class and its overrides or implementations generally have to have like an override modifier. And if you don't put those in, and the editor doesn't tell you, you generally have to go through a few cycles of sending things to the server before you get things right. Well, now Illuminated Cloud tells you about those things immediately. So we'll do a couple of use cases here and just see what I'm talking about. So here's a method that says it's abstract, but it has a body. It's also not in an abstract containing class. So again, using the quick fixes, Illuminated Cloud can help you with this. So there are really a few things that we can do. One thing we can do is remove the abstract modifier. It looks concrete, maybe it is intended to be concrete, but if that's not the case, we can have it remove the body, and we can have it make the containing class abstract, and that will actually fix that. And the same thing with say, a non-abstract. I can add the abstract modifier because this doesn't have a body, or I can have it add a method body that is correct for the method signature. It'll help you correct it either way. If you have a global method, it has to be in a global class. And there's really two ways that I can go here. I can either make the class global, or I can lower the visibility of this method. Let's take a look at the canonical example I started with. Here's a method, and I've actually overridden it in a derived class. Both those are wrong. Neither of those will compile. I need to add a virtual modifier here. Let's go back to the override. I need to add an override modifier here. It'll take care of that. Let's take a look at a few other use cases. I mentioned before that this isn't just for modifier agreement, it's also for annotation agreement. So here's an example of something that is annotated. So R-enabled, an R-enabled method either needs to be static, or if it's instance, it needs to have kind of the getter accessor style naming convention. So I can do either. I can add a static modifier, or I can rename this to get. I'll go ahead and add a static modifier, but it's still not right. It has to have a higher visibility than private. So I can go ahead and make it say global. It'll give me the two that are options. Make it global. Well, our enclosing class is not global. We had the opportunity to do that before, but we didn't do it. So now I'll make the enclosing class global. So you get the idea. This helps you to take care of these types of agreement things that if you don't keep the rules perfectly in your head and apply them perfectly, you're going to have wasted cycles with the server, and that should no longer be the case. Illuminated Cloud should prompt you to take care of that. Another type of agreement that, that people have to deal with, that all of us have to deal with, is scope agreement. And in this case, by scope, I mean class scope versus instance scope. Class constants and class utility methods versus instance methods and instance state that is replicated for each instance of a particular class. So here's an example. In Apex, you cannot invoke a class method like isEmpty from string off of an instance. You can do this in some other languages, and it's flagged as a warning. I actually like that Apex fails this. I like that it fails it because it's misleading. There's nothing instance-like happening here. It's not using the state of string value to do this. So the quick fix just changes it to a reference to the type. And even if that's a chained expression, it will still change it to an instance or to a reference to the type. Now, the other way, for example, using an instance method off of a type, that is flagged properly by the IDE, but there are no quick fixes. There's no way for the IDE to know the exact instance that you needed the length for here. So it will flag it. It can't really help you with that. So let's look at another example of this. This is actually the same thing we saw earlier of needing to access something through the type, but for an enum constant. Here's something that you can't do. You can't reference things like super and this and instance methods and instance state from a class method. So it will flag that. Again, there are no fixes for this. You might remove the static modifier and make this an instance method, or you might need to just move this somewhere else, but it will at least flag it so you know that you have a problem without having to round trip to the server. Okay, so let's take a look at another class of static code analysis capabilities. Again, the whole goal here is to save you cycle times, make you aware of problems as you create them, and make it easier to fix them, and make the options for fixing them obvious to you, and even automate some of those fixes as you've seen. Control flow analysis, if you're not familiar with the term, and I'm going to probably fall into the trap of defining something by using its own name, is used by compilers and parsers and optimizers and static code analysis tools to look at the way that logic flows through an implementation and verify that there are no issues with it, that there are no unreachable statements, that there are no dead ends, that things that get returned are in agreement with what can get returned, things like that. So let's just take a look. Here we have a return statement after a return statement. Well, this one actually returned control back to the caller, so this would never get executed. So it recognizes that and gives you the ability to delete that. And it's not just return statements that can do that. A throw statement can unwind the call stack too, so the same options are available. Moving down, here's an example of something that returns a value, but the method doesn't have a return type. It's a void method. Several ways we can fix this. I can get rid of the return statement. That may be what I want. I can still return from this point. Maybe from a control flow standpoint, I still want to terminate execution of the current method at this point, but I can't return a value. So I can have it delete the return value, or I can actually change the return type of the method to match the returned expression. If there are multiple types, like a query can return a single instance of that type or a list of that type, or if you're querying in aggregate, an aggregate result or something like that, then it will allow you to change the return type of the method. And on the flip side of things, if you don't have a return value, it will allow you to either change the method to void or add a return value. So return virtual treatment. And if you don't even have a return statement, same thing. I can do the exact same thing. So you get the idea. Let's look at another version of this. We'll go ahead and go down here. And this is where I meant there might be dead-end paths. If we look at this, we have basically a switch, and not all branches are covered. So basically we return on this and we return on this or throw an exception on this, but we don't actually return control back here, nor do we at the end of this method. So it realizes that there are dead end paths in terms of the way that things flow back out of here where no value could get returned. So I can uncomment this, that fixes the error, or I can go to the actual error and I can have it terminate the actual method with a kind of catch-all return statement. It really depends upon what it is that you're trying to do. What I was probably trying to do is have a return from that second switch branch. So you get the idea. This allows you to see problems in the way that logic flows through your implementation and fix those before you have to send anything potentially to an expensive server round trip. Let's take a look at one more. Apex Doc validation test. If you're not familiar with Apex Doc, it's an integrated documentation capability for Apex. It's not from Salesforce. I think it actually did originate with Salesforce.org though, but it has become the de facto standard for internal documentation, and there's a reason for that. It is heavily influenced by and actually virtually identical to the same mechanism in other languages: Java Doc, ES Doc, JS Doc. It basically uses a documentation comment / and an at tag syntax to basically provide a meta language for describing your declarations, your classes, your methods, your variables, things like that. Now, Illuminated Cloud has had support for Apex Doc for quite a while, but it was enhanced very recently with two things. One, a code formatter. So now the code formatter knows about Apex Doc and can help you with that. I'll show that in a moment. And in validation. So there are a few issues here. There are two issues here. One, I've declared a parameter, but I don't have a description. The whole point of Apex Doc is to document things, and without documentation, that should be flagged. Notice it's flagged as a warning. The other is it's saying that the parameter order is wrong. Notice we have age and then name, but the actual parameter order is name and then age. So that's misleading, especially if you bring up the documentation for this and you think, oh, I'm supposed to submit age and name if you don't look at the actual signature toward the top. So let's start fixing things. So there is course quick fix. So I'm going to clean up. This is going to run the formatter, which actually corrects things. So that added some space between sections. This is something that I actually have the formatter set up to do. And it rearranged the order of the parameters. And now I can say the name. That problem goes away. The age, and that problem goes away. Now let's look at the next problem. So this one is saying, and I probably just copied this comment from above and put it on no-arg constructor. It's saying it can't resolve these parameters because it is a no-arg constructor. So we'll go ahead and use the same cleanup, and it just removes those. Now let's take a look at this one. There's actually a really convenient way to add an Apex Doc comment. It takes into account the characteristics of the thing you're commenting, and that is just to use the code intention to do so. And then I can just say the account. And now that's taken care of, and probably I want to add description text. And then the last one in here is it's saying that this has a return value, and it does, but it doesn't actually specify the return value. So I'm going to go ahead and do that. And now I'm going to say that this returns the name. So just a nice way to keep your Apex Doc clean and consistent and know when there are issues. And if you make a change to something and don't update the documentation, Illuminated Cloud will help you with that, like the change method, signature, refactoring. I'm going to show in a few. It'll help you with that. But in case you do it and mess things up, it'll tell you about that and you can fix them. Okay, so I actually just provided a nice segue for myself, and that is refactoring. So we've talked about code completion and static code analysis, and now let's take a look at refactoring. Apex refactoring is something that was also added with Illuminated Cloud 2. Several refactorings. I think the first one that everybody wanted was a rename refactoring, and so it has a rename refactoring, and it's quite smart. It will take care of things like up and down an inheritance hierarchy. If something is overridden or if it overrides something, it'll rename up and down the inheritance hierarchy. If something's used elsewhere, even outside of this class or even outside of Apex, if it's used in Visualforce or Lightning or something like that, it'll rename those references. I'll actually show that in a bit. And if you rename a class, it'll actually do the right thing in terms of deploying the new version and all the references to it, and then using destructive changes to delete the old version. And everything's atomic. It can be undone. Extraction refactoring. So I'm just going to show these real quick. I've shown these before. This is all building up to a new refactoring. I can extract a variable. I can extract a constant. I can even extract a method, and we'll just do that here. I'll extract a method, and in fact, to make it interesting, I'll make it a static method. And the reason that's important is you can see that this one actually uses class state or instance state, an instance variable int field. So it has added that as a call parameter because as a static method, it wouldn't have access to that. And so I can just hit return, and it implements the method and exchanges the original expression with a reference to that method. Well, this new refactoring I want to show is called change method signature, and it's one of my favorites. I've been wanting it in Apex for a while. I use it in Java all the time and in JavaScript all the time. It's kind of a Swiss Army knife. I'll let the demo just explain what I mean by that. So I'm going to change this method signature, and I'm going to basically change the visibility to protected, and I'll change the data type to string array, which is the same but different. And I'll just add an X to the name. And on the parameters, I'm going to go ahead and move age down, and I'm actually going to rename age to age X. And I will actually add a new parameter called that it is of type account. Whoops, focus got lost there. That is of type account. You can see that code completion works, and it's actually from the point of insertion, so it's actually quite smart. And we'll just make the default value for existing callers of this be just an empty account because obviously they have to have something. Null would be fine as well. And I'm going to go ahead and hit refactor. And so it did exactly I wanted it to. I mentioned that it would update the Apex doc, and so it updated the Apex doc. It actually updated the caller. It updated all the references to things that were renamed. Now, an interesting thing about it updating the caller is that if this were a method that were rolled out broadly across my code base, imagine a utility method that had hundreds or potentially thousands of invocations, the ripple effect could be huge. So again, this can be you can do an undo on this in a transactional manner, atomic manner. So we'll undo that, and let's do it again. So we'll go ahead and do a change method signature on this again. And I'm not going to do everything. I think I'll just move this down, and I'll change the name here to have an X on it, and I'll add my account parameter. And I want to minimize the ripple effect of this. I'm going to go ahead and change the value to null, the default value, and hit enter. And I'm going to say delegate via overloading method. You can see the new signature here, and I'm going to hit enter. And so here is the changed original implementation. And let's find usages of that. There's only one, and it's actually the original signature. You can even see over here in terms of the version control that all of this is original, and this was added. And it's the original signature, and it's basically delegating with the new signature to the new signature. And now if we look at all the original callers, there's only one, but the original callers of the original signature, they're unmodified. So I just evolved my API without having effectively a broad ripple effect across the code base. It's a very nice capability. All right, so that's the change method signature refactoring that builds on top of all these other refactorings. So let's take a look at something that's not Apex. Let's move on to something editor-wise that's not Apex. So let's go to some Lightning Web Components JavaScript. So if you're using a commercial JetBrains IDE, like IntelliJ IDEA Ultimate Edition or WebStorm or PyCharm, then you actually get to leverage the best-in-class HTML5, JavaScript, ES6, CSS capabilities of those, the ability to directly integrate NPM and jest test execution, things like that. If you're using one of the Community Edition IDEs, this is going to be a little more limited, although you still get quite a few of these features. Now, what you don't get is you don't get kind of a free binding to the Salesforce platform that these imports give you when you're in the ES6 classes for Lightning Web Components. So let's look at an example. So let's say that we want to import, say, a content asset. There's no knowledge of that from the perspective of standard ES6, but Illuminated Cloud is aware of that, and it will show you all of the content assets. You can go ahead and give it a name. It'll automatically use the same name that it can be referenced, by which it can be referenced in ES6. And this is fully integrated with that. I can navigate to it. I can even show a nice little preview of it here. Let's take a look at another example. Let's say that we want to bring in, say, Apex. So I want to bring in an Aura-enabled symbol that I can reference, say a method I can invoke. So it's going to show me all of the Apex classes that contain Aura-enabled symbols. And we'll go ahead and bring in getExpenses, and we'll just invoke that as getExpenses. And again, if I rename this here, this is the thing I alluded to earlier about the refactorings. If I rename this here, let's take a look at what happens. I can navigate to getExpenses, and it was renamed. If I rename it back from here, and I find usages, and I go to this one, This is the one I just created. So there's relational integrity across languages as part of the overall Salesforce development ecosystem. And we'll do one more. We'll do, say, import field. We'll bring in a field. So it shows me the custom objects and standard objects, and then it shows me the fields of those, and I can bring it in, and it gives me a name based on that field name by which I can reference it. And again, this is all linked. I can actually see the declaration of that field. I can bring up the documentation of that field if I want. So it's a really great way while you're developing your Lightning Web Components to be able to access the bindings to the Salesforce platform features. Okay, so now let's move on to some of the tools. We have about 10 minutes left. I want to make sure we make good use of that time. I'm going to go to the query tool first and show you some capabilities here. So this is a query that's already written. It actually is a hierarchical query. As you can see, it queries shopping lists, and then it queries all of the items from that shopping list. And if I execute that query, there are a few different types of queries that could result in extremely slow running, inefficient execution. And Illuminated Cloud will warn you about those. This one says that you have a query with a subquery and there are no constraints on it, no where clause, no limit. This could result in a huge cross product depending upon the data in your database. So it's going to warn you about that. Now I know this is a relatively small amount of data, so I'm going to go ahead and let that execute, and here it is. But the types of things that it'll tell you about, you can actually disable these if they bother you, but are over here. So validate the query syntax, validate the unconstrained subqueries that I just showed, or if you're trying to query blob fields, say the body of static resources, which could be megabytes in size, and as they get transferred over the wire, that could end up resulting in a very inefficient query in terms of what it is you're trying to do. Now, this hierarchical result set, you can see things blown out horizontally. Here's the first child row, here's the second child row. The headers are right here, so you can actually see the information, but it's not a very good way to visualize that. Now, you could copy that out into, say, Excel using this feature, copy results, but you can also visualize that hierarchically using this view. Just switch to the tree tab, and you can actually see the hierarchical view of the exact same data that was just queried. Just kind of a nice feature. Recently also added much better handling of multiple tabs. Originally only default tab was persisted across sessions. Now multiple tabs are. So if we were to, for example, add a new tab here, and we were to say like SD Virtual Dreamin', I can now rename this to the Virtual Dreamin' tab and actually give context to that. And as the IDEs restart, as the OS is restarted, whatever, all your tabs are preserved. The connection that you've referenced, the logging level, things like that. And by the way, I'll show in a little bit how you can actually fully manage your logging levels from here. Now, one of the nice things is, though, is that you can run these types of things not just here, but in other places. So let's go to shopping list. Whoops. So shopping list mobile view controller. I'm sorry, shopping list mobile list controller. And like, here's a query. And let's say we wanted to just see what this query returns. We want to understand it. I can just highlight the query and hit Alt-Enter or Opt-Enter on the Mac and just say execute. And it'll send it over to this tool. And I can just execute it that quickly. And if I want to do the same thing for Apex, I can do the same thing for Apex. We'll just take this single line and I'll send it over to Apex and execute it in Apex. I can execute, I can debug, I can open it in Apex if I want to continue editing it. And this also works with Scratch editors. If you're not familiar with those, it's a JetBrains IDE feature that allows you to send it to basically a file that's not under your project and will get cleaned up in time. But it's just a nice way to go and test things out. And you can send it to a Scratch editor. In this case, this was using a member variable, so let's fix that. So shopping list array, and if I hit Alt-Enter, I can now send this over to Anonymous Apex, and I can execute it in Anonymous Apex, and I continue to work with it there. So a lot more flexibility in how you work with this. Okay, let's go to another tool window, the Log Analyzer. This used to be called the Log Viewer when it was a lot simpler, and some of its capabilities you can open logs from any connected organization. You can hit any of your connections that you've established. You can change logging levels. There's actually a full logging level editor here. I'm not going to go into a lot of detail here, but some of the nice things are you can obviously configure your debug levels and your trace flags. You can actually refresh your trace flags and extend them if you want, just with a single click. So we'll go ahead and send them out for the rest of the day if they've expired overnight and I want to keep working with them. And I can just save that, and those have been saved. But some of the other enhancements here that are really nice. So this is certainly a nice textual view. This is what you expect to see when you see the log. But now you can actually peruse it as a tree. And in fact, I'll go ahead and just maximize that so that we can take a look at it and bring this down. And let's see some of the things we can do. So this is a log for something that was executed. I can browse through it. Let's just kind of page down. Notice that the editor is synchronized as I go through this. This is similar to what happens with the offline debugger, although it doesn't show the call stack. You can still use the offline debugger. You can even start it from here if you want. But in this case, it just shows you the lines that you're looking at from the log correlate to these particular rows in the source code that executed to produce these log rows. So it gives you a lot of information. If you want, you can filter down by debug only even in the tree. And there are other views here. So let's take a look at how those other views come into play. They are used for profiling. So let's go to collection util test. And while this is a little bit of a contrived example, let's say that we have encountered an issue while executing this test for max CPU time exceeded or max heap size exceeded or something like that. So instead of running it through the offline debugger, instead of running it to look at coverage, I can now profile this. If I had not done this before, it would prompt me for a logging level, either sampling or tracing. I think this one was done with sampling, and it will open this up in its own tab. And let's take a look at what we can see. So I will take a look at some of these. It's doing CPU and time and memory profiling. I'm just going to focus on CPU time. This took about 1.8 seconds to execute. Let's see if we can figure out where some of that time went. So I'm going to go over here, and I'm effectively going to just scroll through this until I see one of these a little bit bigger in size in terms of time. Let's see, duration. Oh, this one was 473 milliseconds. That's about a quarter of it. Let's see what happened here. So I can drill in, and what we can see is that this particular method out of 473 milliseconds either directly or transitively consumed 469 milliseconds. So it's expensive. And now we have a section that actually consumed pretty much all of that. And we can see under that it was here that the time was spent. And if we look at the line above, we can actually see that that time was spent inserting users. That's an expensive operation in Salesforce. So that actually makes sense. If we do the same thing with memory, say we have a heap issue, then I can see here that I have one test that took about 3 times as much memory as anything else. I can drill in and I can see where that memory went. So not much, not much, not much. Here's about half of it. So let's drill in, and we can see that most of it went here, again, drilling in. And now what we're seeing, if you watch the editor up there, we're just in a tight loop. So each one of these iterations of loop took about an 11th of the time. So if we drill in, we can see where the time went. And it looks like it basically ended here, and it's metadata introspection. So it may be, that tells me that maybe I can group those together because I'm in a loop and I'm getting that. Maybe I can get those once and cache them, and I can say, or in this case, it wasn't time, it was memory, and maybe the memory overhead would be lower. Maybe not. Maybe this is just what it takes to get those. Let's look at one more example of this. So I'm going to go to shopping list mobile list controller test, and I'm going to execute this. And I'm sorry, shopping list mobile view controller test. I'm going to execute this, and let's say that this one, for profiling, let's say that this one had too many, like a SOQL query limit exceeded, or too many DML rows, or something like that. Well, let's switch over to database profiling. And now we can see where those database rows and queries were executed. So there were 3 queries here. Let's drill down and see if we can find them. If it is in a black or a solid font, it means it was exactly there. So you can see that query in the editor. If we go down 2, you can see this query in the editor. The gray means you need to continue to drill in. Now we can see this one. There's that 3rd query. And the same thing's going to hold for looking for DML statements and DML rows. You can do the same thing. So it allows you to profile and isolate hotspots, and then you need to figure out how to optimize that. It may be that you have to bulkify. It may be that you have to switch over and use async or something like that. Okay, we have about 2 minutes left. A couple other things that I want to show. So comparators test. Let's go over here and let's debug this. I'm going to show a couple of debugger enhancements. So this is the offline debugger. I'm executing it, and I want to show a feature called Smart Step Into. And I'm also going to show a feature that is inline variable hints. So I'm going to step over this. Now this particular line actually calls sort, but it calls sort on a list of integers, and it calls sort on something that's using a Fluent API. And let's say that I don't want to have to step into everything there. So I'm going to use Shift F7 to step in instead of just F7, and it's going to show me the order of execution of these. So let's say I want to step into ascending, and I can step into just ascending. Also notice here that variables are now shown at the point of declaration. The values are. They're also shown in the variables view, but they're shown here at the point of declaration. So I'm going to step out. I'm going to do a smart step into again. And I stepped into sort. Let's step over. Okay, let's step in here. Do I want to step into the constructor or into the add method? Let's step into the constructor. And I'm going to start stepping over. And again, you can see the variables view. You can see things being assigned here very conveniently in the editor. So smart step into and variable value hints in the debugger. Gets closer and closer to being a real debugger. You can see the object value changing there as I step through right in the editor. Okay, so we'll let that go. Okay, one last thing I want to show. I have 20 seconds before we want to move over into Q&A. Just this week, I introduced and I'm going to go to the package XML. I introduced a new feature for the subscription editor for package XML. So this is the subscription editor that's always worked with selected, but now it actually works with package XML files, which is very important now that people are doing source format development against non-Scratch orgs, and your subscription is always based on package XML. So let's see what happens here when I just hit the apply button. And notice that it just added analytics snapshot. Let's say a wildcard Apex class and hit the apply button. And there we go, wildcarded. If I remove account extension and apply again. So it's editing that, and also see these comments that are in there. It's doing it in a very non-destructive, respectful way of retaining your comments within this, assuming that some of them may be blocks of code of elements that you might want to restore. Some of them are annotations. So feel free to use the visual editor. Excuse me, when you're editing your metadata subscription, whether you're using a selected subscription or a package XML subscription. All right, I'll stop there, and we will go ahead and move into Q&A.